we are going to dive into 1.2 today. Just so you know, those of you who grabbed the note page on the way in, good job. If you grab the other sheet, we'll talk about that here in a minute. But you need a note page. And just hold on before you get up. Just a reminder, our title up here, 1.2, Transformations of Linear and Absolute Value Functions, found on those pages. These are our learning goals. This is what we're going to go through today. All right? The essential question will go with our exploration here in a minute. All right, so here in a minute, you're going to grab your note page. If you haven't done so, you can copy that down, but then we're going to dive into our exploration, which is on page 7 of your student journal. So every day, you might as well grab your student journal just in case. For those of you who tore it out, you already have it. Okay? Go for it. All right. Eyes and ears focused up here. You'll have time to finish copying this later if you haven't done so, or the part of you don't have to copy learning goals, but it's nice to have the title and the page numbers. If you haven't done that yet, that's okay. I want you to look at your student journal, and on page 7, right now with your groupings, I want you to complete exploration 1, 2, and 3. It's on page 7 and 8. Okay? We're going to work on that for about 10 minutes. Now, the first part of these explorations should be a piece of cake compared to what we've been doing. Relative to what we've been doing, this information up here on exploration 1 and 2, not too bad. Okay? It's when you move to exploration 3, it gets a little different, and then answering these questions. But it should be a real quick review of what we've done and maybe a little added new. Okay? So work with the partner, person next to you, spend about 7-10 minutes on it, and then we'll move on. Hopefully your exploration went pretty quick and easy here. So compare the graphs to the parent function. What does k do? Good. If we add k, it moves it up. If we subtract k, it moves it down. All right. And I'm going to go to a different format or function notation here in a minute. But what does h do? Shifts it left and right. Now remember, if we subtract h, it shifts it which way? Shifts it to the right. If we add h, it shifts it left. Okay. Now, I'm going to pause for a minute. Now, I know, well, it's not really free. You're paying taxes, but that's okay. You're not. Your parents are. All right. But it is free for you, yeah. Okay, so there we've got it. Remember, when we're dealing with h, and this is going to become more evident today, it's counterintuitive to what we think. If we think minus, we usually go to our left. Well, minus h here, you go to your right. Okay? H is always inside grouping symbols. K is on the outside of your grouping symbols. So that's kind of our quick review. And then from Friday, we also talked about reflections. And reflecting over the x-axis is when it's on the outside. It's like a reflection. It's like having -1 out there. It reflects it upside down. So we call that our a value. If our a is negative, we're reflecting over x. All right. So, how do these graphs compare? Well, notice what they're doing here. They're using function notation now. They're saying y equals f of x plus k. F of x stands for whatever our function is. So you're going to see that a lot today. And notice here they've put the h in with the f of x, with the x there. And here you got the negative f of x. How does it compare to the parent function? Well, that's kind of what we just talked about, where h shifts it left or right. This reflects it over x. And this shifts it up or down. Okay, any questions up to there? I'm flying through that pretty fast because I want to give us time when we start talking about the horizontal information later. It gets really tough. So what's happening here? Good. The -4 is making it shift down forward. Okay? What's happening here? So down 4, this one goes left 4. Okay? What happens here? reflect, holy cow, what happened there? Reflect over x. Thanks for telling me. Thank you. Now we can, right? You guys have to let me know if I'm off the screen. I don't see it. Okay, what's happening here? Up one. Here? Right one. Here? Reflect over x-axis. Okay. Any questions? Matt, your question earlier about horizontal stuff is a good question. We're going to actually see that here in a minute. Okay? So, when you take a look at page 9 of your workbook, it kind of summarizes some of this stuff, the horizontal shifts and the vertical shifts, stuff we've talked about. It gives some room for you to take notes if you'd like. So if you want to reference that page later, you definitely can. The same thing on page 10, it talks about the reflection. But this one, it says reflect in the x-axis. It shows the negative outside the f of x. Notice they're saying when y is equal to f of x. So in other words, we're calling this f of x, or f. Negative f of x, when the negative's on the outside of your function, like that, it's reflection over x. Now notice what happens when you put the negative inside. So when the negative goes in with the x, it's a reflect over the y-axis. So what you really have to remember is if you are moving your values on horizontally, it's happening inside parentheses. If you're moving your values vertically, which is what's happening when you flip it this way, when you flip downward, you're moving it along the vertical scale, it's happening outside. Horizontally, flipping it this way, it's happening inside. Okay, you're multiplying your inputs by -1. It changes their signs. And then we get to the tough stuff. Now, I was talking to a pre-calculus teacher this weekend, and they're saying they cover this in pre-calculus. We've never covered it in trig before. So you guys will get the first group that we cover horizontal shifts with. You are lucky, lucky dogs. Okay? So a horizontal stretch and shrink. When you are moving things left or right on the y-axis or on the x-axis, when you are stretching it by a factor of, or stretching or shrinking by a factor of a. Okay? And it's counterintuitive. Like when we move to the right, we are subtracting. Well, when you are stretching something, you are actually multiplying. You are multiplying by 1 over a. Versus when you are shrinking something, you are actually multiplying by a larger value. So if I say I want to do a vertical shrink of 2, a horizontal stretch of 2, you are multiplying by 1/2. It's weird. So we'll go through that here in a minute. I know it's kind of different. I know. So we'll hit on that here in a minute. Okay, but please note that when you're doing horizontal stretches or shrinks, you're moving it in relation to your y-axis. You're actually moving it this way or towards. You're moving it away from the y-axis. So this line right here, let me highlight that line to be a little easier to see. This line right here, when I'm doing a stretch or a shrink, if I am stretching it, I am actually moving it a factor away from the y-axis. Versus when I'm shrinking it, I am actually pulling it towards the y-axis. Okay? You're like taking this line and pulling it this way away, or you're taking this line and sliding it this way. Everyone understand what we're saying? Okay? It's kind of here, yeah. You're kind of, it's not really a rotate. I mean, it's kind of a rotation, but you're pulling it. It's like taking the ends of it and pulling it away from the y-axis or pushing it towards the y-axis. Okay, that's what a horizontal stretch or shrink is. And if it's vertical, then you're pushing or pulling away from the x-axis, which is actually what the next page is. So like when you're doing a vertical stretch or shrink, which happens on the outside because you're changing things vertically, you are actually pushing or pulling towards the x-axis. Okay, so if I'm doing a stretch, I'm pulling it away from the x-axis, whereas if I'm doing a shrink, I'm pushing it towards the x-axis. So I'm taking that line and either pushing it downwards towards it or pulling it away from it. Okay? Kind of weird. I know. The horizontal stretches and shrinks, the vertical stretch. Vertical isn't as bad. Horizontal will get really weird. Okay? So, what I'd like to do with you right now is I want to go ahead and try some problems out of your book. All right? And you don't need your book for this. I'm going to just project them up here. Okay? These are from example 1. We actually don't need that page. Let's go into monitoring progress right there. I want you to take a look at that. Okay? You can just talk about it. You can write them down. But you're going to take f of x and translate it 5 up. So write your new function. Same thing with number 2, but you're translating it 4 to the right. Write your new function. Okay? You're going to write your new function as g of x. Okay? Go ahead and work with your groupies here. Get a few minutes on it. All right, ladies and gentlemen, let's go ahead and talk about these. I don't expect you to be done with them all, but I do expect you kind of started up on them. Guys, remember, if you're doing a translation of 5 units up, what I like to think of, if I'm dealing with this, I like to think of writing it in function form first, especially when you're learning it. It helps you out. So if I'm doing a translation of 5 up, that means g of x, my new function, which we're calling g, is going to be f of x plus all plus 5, right? Everyone understand what I did there? So we're using f of x notation. So when we're moving an up or down, that's a k shift, and k goes on the outside of f of x. How many are with me? Yes. Okay. So k goes on the outside, h goes on the inside with f of x. So I'm not done with the problem yet. Okay, g of x is equal to f of x plus 5. Well, we know f of x equals 3x. So what do? We put 3x in for the f of x. So 3x plus 5 equals g of x, which says, if we want to rewrite it, g of x equals 3x plus 5. Now, many of you said, well, dude, I did that, but I didn't do all this other junk you just did. I just said 3x plus 5. Just added 5 at the end. Well, that's fine. I'm trying to teach you a process I'm going to use for when they get more difficult. Okay? How many are with me there? Okay, any questions? No? All right. So here, a translation 4 units to the right. Is that in with x or out with x? Out of x. It's in. So we know that g of x is going to equal f of x going to the right. So we're going this way. That's a minus 4. Is it minus 3? No, it's minus 4.
Yeah, no, outside.
Oh, yeah, I know what you're saying. Okay? So what we're going to do is we're going to plug this in now. We're going to say f of x. So rather than have x minus 4, we know that f of x is this right here. So wherever we see x in this, that's what we put in for x. How many remember back in algebra, we give you something like x plus 2. F of x equals x plus 2. And then we said, okay, what is f of 6? How many of you remember doing that in algebra? What did you do with that 6? You put it in for x, right? You said, well, that's just 6 plus 2, or that's 8. That's so easy, McCoy. Yeah, that's all you're doing here. You're saying f of x minus 4. What are you doing with that? You're putting it in for this x. Okay, so you now have the absolute value of x, which we're not calling x, we're calling it x minus 4, all minus 3. That's g of x. Do you have to have parentheses? No, they don't matter right there. G of x equals x minus 4 minus 3. But once again, some of you are going, you're making this like harder than it needs to be. I got that. I didn't do it that way, though. The problems are going to get more difficult. That's why I'm making it. I'm doing this with you. Okay? Reflect on the x-axis. Is it doing a vertical or a horizontal reflection? Over the x-axis, which is this. So if I'm going from here to there, did I go vertically or horizontally? vertically. So am I changing x or y? Changing my y values, right? X values are staying the same. Changing the y values, which means it happens on the outside. So if I'm doing a reflection in the x-axis, do number 3 down here, saying g of x is equal to, so I'm doing negative f of x. Thank you. You guys with me? What is f of x? Negative, and I've got to replace f of x with this. This is f of x. How do I know? Because it says f of x equals that. Now, this is where some of you messed up. How many have an answer for this one? Okay? Be careful. Negative times negative is positive, which most of you have right. The mistake you made, some of you, is that's negative times negative, which is plus 1. See how the function notation will help you a bit? This is not easy. Like, Mr. Vogel and I, we're talking about doing this, and we're like, man, how is going to be the easiest way to teach them this? Because it's very confusing at times. Okay? Reflection in the y-axis. So, I have the y-axis now, and I'm reflecting over. Am I changing x or y's? Changing x's. Okay? So, here, oops, excuse me, not there. Let's move it down here. All right, so g of x is equal to, does it happen inside or outside the reflection? Inside. Happens inside because we're changing our x. So it's an f of negative x. Once again, that can be really, really confusing if you don't think about it like this. Just drop back to what you know. It's like climbing a tree. Use the thing, like the branches. These are things you know. Hang on those, okay? So you know that if I want to find g of x, I take and I plug negative x in for the x up here. So I'm going to have 1/2, and then that's where the x is, plus 1. I'm going to plug negative x in where x was. So I end up with negative 1/2 x plus 1. How many got that one? Okay, everyone rate themselves 1 to 5, like on understanding right now. I want to know where we're at. Okay, getting there. How many are found some stuff confusing up here? Okay, let's try some others here. Give that one a go. Number 5 and 6. Work together. Okay, number 5. Number 5, horizontal stretch by a factor of 2. So does that happen, like when I'm writing it out, g of x equals f of, so does it happen inside or outside first? Is it moving horizontally or vertically? Horizontally goes xy, so does it happen in or out? Happens in. Okay? Now, horizontal stretch by a factor of 2, everything's counterintuitive. So you'd think you would multiply by 2, but you divide by 2 or multiply by 1/2. When we start graphing it, it'll make more sense. Okay? But you're doing a horizontal stretch by a factor of 2, which means you're moving the value towards, well, let's just wait until we graph it. It'll make a little more sense. Okay? So, in that case, that gives me g of x equals, and now I'm going to plug the 1/2 in for x. So it becomes 4 times 1/2 x plus 2. Or g of x equals 2x plus 2. Okay, tell your neighbor how you did on that one. Then review the next one. Okay, here we go. Vertical shrink. So is this happening on the outside or inside?
Outside.
Outside. So we have g of x equals vertical shrink of 1/3 f of x. You don't change it to 3 on the outside. Remember, inside is where it messes up because you're dealing with input values. Versus the outside, you're getting an output value. You go normal mode on the outside of f of x. On the inside of f of x, everything's counterintuitive to what you think. It's like you're in Bizarro world in there. I'm just saying, it messes with my mind. I'm so logical, you really have to understand it to kind of dive in there. So, anyway, that gives me 1/3 of f of x, which this is f of x, right? F of x equals that, so we take 1/3 of all of that. Absolute value of x minus 3. So be careful, right? Because now you distribute the 1/3. It becomes 1/3 of absolute value of x. So that brings there, and this goes, that's minus 1. Now,
so you were wondering, well, does the fraction always stays outside of the absolute value bar?
yeah, you don't drop it in because then you'd be dealing with the 1/3 inside here, right? If you brought it inside the absolute values, then it's coming into your input area. Good question. All right, 1 to 5. How are we doing? Moving on up, it looks like. That's good. Okay. All right, I want you to describe that. Hey, let's check it out. Hey, when we're dealing with these, here's how you should deal with it. Work from the inside out. So like when you're given the function and you're trying to describe it, work from the inside outward. So this right here, inside here, what's happening? So right 2. And then, what's attached to it? Well, this is being added. This is being multiplied. So deal with this block here. Vertical shrink of 1/2, and then up 3. Now, you guys, please note that this right here, wherever you could have put right 2 anywhere, you could have made it the first thing, the second thing, or the third thing. This, because it's moving horizontally, this is going this way. It's the only part of this that's moving horizontally. Both this and this are moving vertically. Therefore, order is going to matter there. The vertical has to come before the translation. If you translate and then do a shrink, you did it wrong. You can't, if you slide this and then shrink it, you're actually having to distribute that 1/2 in. Remember what we did in that previous problem right here? If we're dissecting this, we're actually saying, hey, we're taking x and we're doing a vertical shrink of 1/3 and then moving it down 1, which is right, but when we look at it this way, we're actually saying we're taking our graph, our function, and we're moving it 3 and then doing a shrink of 1/3. Does everyone understand what I mean there? So your order is important right here. Okay, here, this could have been put anywhere because it's the only horizontal piece. Okay. Any questions? All right, you guys, that's tough stuff. This is going to be your assignment right here. I'll hand it out, and we may end up spending another day on 1-2, or we may not. We may just move to 1-3 tomorrow. I got to talk to Mr. Vogel and see how his class went with it. So, but anyway, for today, I'll get you